Hello everybody, my name is Nguyễn Ngọc Thân. Today I would like to present about an optimal eigenvalues-based decomposition approach for estimating forest parameter over forest margin area. My presentation consists of 5 parts. Part 1, introductions. Part 2, basic scattering mechanism in forest margin area for PolInSAR and simplified Newman volume scattering model. Part 3, the optimal eigenvalues-based decomposition of PolInSAR data. Part 4, applied data sets and experimental result. And Part 5, conclusion. Part 1, introduction. Polarimetric interferometric synthetic aperture radar PolInSAR is a time remote sensing technique which combines the advantages of polarimetric SAS and interferometric SAS. Especially polarimetric and interferometric SAS data have been designed for forest biomass estimation. And applying the model-based decomposition to polarimetric interferometric synthetic aperture radar data is an effective approach to suppress scattering mechanism in the natural environment. In commonly applied decomposition techniques are mainly divided into two categories. One, coherent decomposition based on the measure single-line matrix, and 2, incoherent decomposition based on the measure coherencies and covariance matrix, in which the three-component decomposition of Freeman-Dusen is one of the most popular ones. Accordingly, the gross correlation PolInSAR matrix obtained from observation can be described as the sum of three matrices, and each representing the contribution of volume, ground, and double-bound scattering component. However, some major shortcomings have been pointed out when applying these methods, such as negative power of ground scattering and double-bound scattering component, and assumption of scattering reflection symmetries for volume scattering component. For the reason, we propose an eigenvalue-based decomposition approach for estimating forest parameter over forest margin area using single baseline L-band PolInSAR data. In this approach, we shall suggest a simplified Newman volume scattering model, which is characterized by the randomness parameter. This model is useful to overcome the limits of scattering fraction symmetry assumption. This volume model includes both random and non-random volume situations, so it is suitable for volume scattering mechanism on slope terrain. After that, the unknown parameter of the volume scattering matrix are determined as well as the parameter of the remaining scattering mechanism are estimated by using the optimal eigenvalue-based decomposition technique. Two, basic scattering mechanism in forest margin area for PolInSAR and simplified Newman volume scattering model. For PolInSAR, the obtained full polarimetric interferometry information data can be expressed in the form of two scattering matrices, S1 and S2. The target vector KL1 and KL2 in the lexicographic basis, which are measured at the two ends of the baseline, are shown in equation 2.1. Accordingly, we can form the PolInSAR covariance matrix by multiplying the target vector by the conjugate transpose as described in equation 2.2. in which T1 and T2 matrices are polarimetric covariance matrix for the two aperture, whilst omega E a matrix between the aperture and it contains both polarimetric information and interferometric information. The matrix omega can be decomposed into three submatrices, TV, TD, and TG, which correspond to the volume, double bound, and ground scattering mechanism as described in the equation 2.3, where FV, FD, FG correspond to the contribute of volume, double bound, ground scattering, and VV, VD, VG are the phase of three scattering components. Three volume scattering mechanism and simplified Newman scattering model. The scattering from the tree canopies can be described by a multitude of randomly oriented particles. Newman proposed the von Mises distribution for the orientation of particles. Accordingly, two coherence matrices are obtained in the equation 2.4, in which TSV and TVV are horizontal and vertical simplified Newman volume scattering model, with tau denotes the normalized degree of orientation randomness. In case tau equal 1, then TSV equal TVV. The co-polarization power ratio gamma omega is able to distinguish the two types of the volume scattering model. We can derive gamma omega from cross covariance matrix omega, and for each values of tau in the range 0 from 1. The ratio gamma TV tau can be obtained from the volume scattering matrix TV tau. Therefore, the optimum tau can be determined when the difference between the two ratios is minimum, as described in equation 2.5. When tau is computed for each pixel, the corresponding volume scattering matrix TV is determined. The figure on the right shows an algorithm flowchart for determining the volume scattering matrix. For ground and double bound scattering model for slope terrain. For slope terrain such as forest, mountain area, variation of topography and the local orientation angle due to the local terrain will lead to the change in the scattered signal. A local coordinate system is formed to accommodate in inclined ground surface. In order to represent the scattering component in the forest mountain area, the flat double bound and ground scattering component are replaced by the scattering from the inclined ground plane. In this case, the coherent scattering matrix for the ground and double bound contributes is created from rotation of a local orientation angle, as represented in equation 2.6, with kappa and eta denote the influence of terrain slopes on the double bound and ground scattering mechanism. The parameter kappa is between 0.5 and 1, and eta vary from 0 to 1. Two parameters alpha and beta are a parameter of the double bound and ground scattering as proposed by Predictive. 3. The optimal eigenvalue-based decomposition of PolInSAR data. In this section, we propose an optimal eigenvalue-based decomposition approach for PolInSAR data to estimate vegetation parameter in mountain terrain. The approach is conducted in 3 steps. First, the term of the volume scattering mechanism are identified. Next, the algorithm for analyzing the eigenvalues of the residual matrix is applied to determine the parameter of ground and scattering mechanism. Finally, height is estimated by the canopy and ground phase difference. From decomposition equation, we can transform as described in equation 3.1 by determining the eigenvalues of the matrix omega r. We can obtain canopy phase phi, v, and volume coefficient f. We assume that phi, v, fv, kappa, and eta are input load parameter with kappa from 0.5 from 1 and eta from 0 to 1. For each value set, phi, v, fv, kappa, eta, the residual matrix that contains the remaining 2 unknowns alpha beta can be obtained. We perform the eigenvalues analysis for this residual matrix as described in equation 3.2, where lambda and k are eigenvalues and eigenvector of residual matrix. We see that the minimum eigenvalues of residual matrix is 0 when the volume scattering component is completely removed from PolInSAR data. As suggested by Cloud, the parameter alpha is one of the main parameters for determining the dominant scattering component in independent targets. In this paper, we use an equivalent parameter mu to identify the dominant scattering mechanism. This parameter is determined in equation 3.3. In case mu less than or equal 1 for all it, the ground scattering component will be dominant and the parameter of the 2 scattering components are determined as described in equation 3.4. In case mu is smaller than or equal 1 for all e, the double bound scattering is the most dominant scattering and the parameter are determined as described in equation 3.5. On the contrary, if mu greater than or equal 1 and mu g small than and equal 1, with E different G's, both scattering components exist in the residual matrix omega R. The parameter of the two scattering components are determined as described in equation 3.6. Based on the obtained parameters, the forest height can be estimated by the difference between the canopy phase and surface phase as in equation 3.7. To assess the effectiveness of the probable methods, a dataset that is acquired from PolInSAR software is applied. The software performs data processing and it can generate simulate forest scenario with similar parameters in the actual scenario. So image of poly-ghost forest scenario is shown in the figure on the left. In this paper, we extract the result for analysis along the transects marked by the red line. Figure on the right shows the trees forest height estimated by the optimal eigenvalues-based decomposition approach. The tree height obtained is complex consistent with it in the simulation scenario. In these pictures, most peaks of tree height are local as 18 meters. As some pixel tree height is estimated to be higher, but still less than 22 meters. Therefore, we can conclude that the estimate result from the proposed methods are accurate with small error rate. In order to further demonstrate the effectiveness of the optimal eigenvalues-based decomposition methods, we compare the result of the optimal eigenvalues-based decomposition approach with those obtained from the three-stage inversion methods. This comparison is conducted in the transect line. The results are detailed in the image above and the table below. Therefore, the estimate result using these methods are more accurate based on the mathematical principle of eigenvalue analysis. The proposed methods determine the optimal parameter for the forest vegetarian on slope terrain. Therefore, the estimation results are significantly improved. Next, we apply the probable methods to the satellite data sets obtained from the ALOS system PASAS on March in 2007 for the first time and the second time on the April 2007. This includes a pair of the image of area as Indonesia. PolInSAR satellite system is operates at 1.3 GHz frequency with baseline 330 meter and incident angle E 21.5 degrees. Figure on the right shows the SS polarized image of the survey area, and the result of the proposed method is shown in figure on the right. This figure proves that most trees high on forest area is appropriate 20 meter. A table at the top shows the detailed result in the forest parameter estimation using the proposed methods for the survey area. The amplitudes of the ground, double-bound, and volume scattering mechanism are shown in the figure below. For VV polarization channel, the volume scattering is the dominant component. For SS cross polarization chain, the contribution of the double-bound scattering component increased significantly. However, due to the slope of the terrain, this scattering mechanism is still not dominant in the vegetation area, and contribution of volume scattering is still the largest. The results are completely consistent with the definition of ResNet coefficient, in which the SS contribution exceeds the VV contribution. 5. Conclusion. A method for estimating vegetation parameter over forest margin area based on optimal eigenvalues-based decomposition technique has been proposed in this paper. The proposed decomposition method is implemented by introducing a simplified Newman scattering model to fit the observer data on slope terrain. Forest parameters were obtained by the optimal eigenvalues analysis technique. In addition, scattering power and contribution of the scattering component are also estimated. Simulate that data and experimental data from satellite system have been used to test this optimal eigenvalue algorithm. Obtained results indicate that vegetation parameter can be adjust direction and accurately. In the future, experiments will continue to carry out on different terrains to more fully assess the effectiveness of the proposed methods.
Ladies and gentlemen, today I'm here to present to you about an improved forest height inversion method using dual-polarization PolInSAR data. My name is Thieu Hữu Cương and I'm from Le Quidon Technical University in Hanoi, Vietnam. The organization of this report is as follows. It includes 4 parts. Part 1, Introduction. Part 2, Extended 3-stage method. Part 3, Methodology. And Part 4, Experimental results. I will start with some general information about extended 3-stage method, PolInSAR system, and proposed method. Part 1, Introduction. Forest height is one vital parameter to serve forest management, monitoring, and protection activities. Along with the strong development of science, technique, and technology, many methods have been applied to improve the effectiveness of the mentioned activities related to forest. The fully polarimetric PolInSAR system provides full information and a more complete description of the vertical structure of the forest. However, it does not have high resolution and its viewing area is not large compared to the dual-polarization PolInSAR system. Hence, the dual-polarization PolInSAR system can meet the requirements of large-scale surveys and global survey. In the suggested approach, the topography phase is estimated based on the mean coherence set theory. After that, a comprehensive search method to identify the polarimetric channels corresponds to the volume scattering component. Finally, the forest height is extracted by comparing the forecast model with the optimal volume coherence factors for the scattering component directly from the canopy. Thus, the suggested approach not only improves the efficiency of the extended three-stage inversion method, but also lessens the complexity in the calculation. Part 2. Extended three-stage method. In 2016, Fu Wing Su suggested the extended three-stage version manner by dual-polarization PolInSAR data. This method is divided into 4 stages. Stage 1. Compute the HH and the HV coherences and the optimization coherences. Stage 2. Determination of ground phase by TLS method. Stage 3. Search the volume-only coherence on the ambiguous line segment. And Stage 4. Height and extension estimation. The extended three-stage inversion method has significantly improved the effectiveness of estimating forest parameters compared to the three-stage inversion approach. However, this method still has some drawbacks, which causes large errors when calculating forest height. From the mentioned reasons, this article suggests that an advanced forest height conversion method using dual polarization channels PolInSAR data for accuracy improvement in extracting forest parameters. Part 3. Methodology. 3.1. The dual polarization channels PolInSAR system. The scattering vectors of two polarization channels PolInSAR system will not have the VH and VV polarization components, and the scattering vectors is expressed in equation 1. Then, the coherence matrix and cross-decorrelation matrix of dual PolInSAR system become level 2 square matrices as equation 2. The complex interferometry coherence coefficient of the dual polarization PolInSAR system is presented as equation 3. 3.2. Estimating ground phase based on the mean coherence set theory. The ground phase is determined by the following formula, wherein B is defined as in equation 5. 3.3. Estimates of forest height include: in this case, the polarization vector is a two-dimension complex unitary vector and is represented as equation 6, where alpha and psi are real coefficients and satisfy the conditions in equation 7. A set of complex interferometry coherence coefficients will be determined according to the following condition. With the set of complex coherence coefficients satisfying the condition 8, we can completely estimate the HV and HH polarization channels from equation 9, in which the distance between the estimated channels and the two polarization interferometry channels is as equation 10. The coherence coefficient of the optimum polarization channel will then be determined according to condition 11. Part 4. Experimental results. The effectiveness of the suggested approach was assessed with simulation data generated from the PolInSAR ProSim 5.2 software. Simulation data is received from the PolInSAR band L system and at the central frequency of 1.3 GHz with a baseline of 20 meter horizontally and 1.5 meter vertically. The surveyed forest area has an average wood height of 20 meter over place on a relatively flat terrain. The surveyed forest covers an area of 2.8274 kilometers with a distribution of 900 trees per hectare. Figure 5 illustrates a poorly color image of the observed forest area of 221 x 259 pixels. The effectiveness of the proposed model is assessed by comparing the results of the suggested approach with the extended three-stage inversion manner. Figure 6 is a chart comparing the topology phase that is detected by the proposed manner, the black line, and the extended three-stage inversion algorithm. It can be seen that the estimated ground phase of the mean coherence set method has an average of 0.0982 radian and fluctuates while close to the true topology phase. Meanwhile, what is estimated by the line fit method has an average of 0.1585 radian and usually oscillates over a relatively wide range, and it has a large error compared to the true topology phase. Thus, the ground phase estimated by the suggested approach gives higher precision and reduces the computation time compared to the extended three-stage inversion method. Figure 7 is a line chart comparing the detected forest heights from the suggested approach, the red line, with the extended three-stage inversion procedure, the blue line. Figure 7 indicates that the average estimated forest height of the suggested approach fluctuates steadily around a height of 20 meters, except for some pixels that exceed 21 meters. Meanwhile, the volume height estimated by the extended three-stage inversion procedure often oscillates strongly in the range from 16 meters to 19.5 meters. Especially there are some pixels lower than 12 meters. Although this method has significantly improved the accuracy better than the traditional three-stage method, however, the estimated forest height has not yet been highly effective and stable. Table 2 shows the forest height estimated by the extended three-stage inversion manner and suggested the approach with average value of nearly 19 and nearly 20 meters respectively, with actual forest height in the simulation data of exactly 20 meters. We can see that the accuracy of the tree height estimated by the suggested approach is higher than that in the standard tree stage inversion method at an amount of 4.67%. In addition, an important parameter is representing the accuracy of the forest height estimated by the two methods is the root mean square error (RMSE). There are 3.062 meter and 1.582 meter respectively. The value of the suggested approach is smaller, meaning that the efficiency of volume height estimated of this method is higher than the standard three-stage inversion method. Furthermore, the other parameters in Table 2, including surface, phase, and the mean extinction coefficient estimated by the suggested approach, also show high accuracy and are close to this value of the system. Figure 8a is a 2D image and Figure 8b is a 3D image describing the wood height in the entire surveyed forest detected from the suggested approach. It can be seen that the pixels are shown in 2D and 3D. They are mostly concentrated at 20 meters approximately. There are some pixels higher than 20 meters, but not significant. From the result shown in Figure 8, the suggested approach is relatively accurate and reliable. After that, to analyze the influence of the tree species on the accurate forest height retrieval of the suggested manner, we apply the proposed manner and the standard three-stage inversion method with the simulated forest areas having different tree species: coniferous forest, mixed forest, and broadleaf forests. In the simulation data, we only change the tree types. The other parameters remain unchanged. Figure 9 describes the forest height estimated by two methods with three different tree styles. We can see that the forest tree species of the conifer family, the pine, often cause large errors for the estimated result in both methods. The main reason is that with the forest trees belonging to the conifer family, scattering waves easily penetrate to the ground, and then central phase of the ground scattering and mass scattering components are relatively close together. Figure 9 represents the result of estimating forest height of the two methods, with a change corresponding to the simulation data of each different tree species. However, because the density set for the initial simulation data was 900 trees per hectare, it was relatively favorable with the backscattering of radar wave. Therefore, the estimated forest height results in this case are not much changed. From this figure, it is again shown that estimated forest height of the proposed algorithm is always more accurate and flexible than the standard three-stage manner. In conclusion, the paper has researched and developed an accurate method for estimating forest height from dual-polarization PolInSAR images. In the suggested approach, the terrain phase is first determined based on the mean coherence set theory. Then a comprehensive polarization channel search method is proposed to extract forest height and average wave penetration factor. Experiment results indicate that the accuracy of forest height detected by the suggested approach was enhanced by around 4.65%. In comparison with the standard three-stage one, in the incoming years, the suggested approach can possibly be applied to different types of data and in different forest areas to optimize the efficiency a suggested approach. And that brings us to the end of my presentation. Thank you for listening.
Hello Professor, I am very happy to be able to attend the conference today. I am going to lecture on an attempt to perform TCP ACK-Storm based road attack on virtual and Docker network. The authors include Thanh Trần Nam, Thanh Nguyễn Kim and Thanh Tạ Minh. We are from Lê Quý Đôn University, Hanoi, Vietnam. The presentation includes 4 sections. First, introduction, describe ISO and our contribution. Second, related work, describe technology and technique related. Section 3 is experience, describe experience in VMware and Docker and propose new attack method. Eventually, Section 4 is conclusion, discuss about feasibility, countermeasure, and future research direction. As the evolution of technology, the virtual server market is growing fast. However, recent studies show that virtual servers are more vulnerable than traditional servers, so that we did the research. Our contribution includes warning about the risks and security vulnerabilities in a virtual environment, prove feasible to attack service on a hypervisor system, propose a new attack method based on ACK-Storm attack with Phoenix package, and offer some solution to prevent and decrease the destruction of the time attack. Let me introduce you briefly about VMware Workstation. Virtual machines are software computers that provide same functionality as physical computers, have run different software requesting different environment. Hypervisor may be called a virtual machine monitor, can be hardware, software, or firmware that provide virtualization capability. A hypervisor allows one host computer to support multiple guest virtual machines by virtually sharing its resources such as memory and processing. Virtual Switch or vSwitch is a software application that allows communication between virtual machines, between the physical machine and virtual machines. Virtual network or network virtualization is a method of splitting up the available bandwidth into channels to combine available resources in the network. X of channel can be assigned or reassigned to a particular server or device in real time and is independently secure. Move to Docker. Docker Engine or Docker daemon is a background running service that manages everything required to run and interact with Docker container on the operating system. It's used to run Docker container which span up all application dependency inside. Docker container image or Docker image is a lightweight standalone executable package of software. It includes code, runtime, system tool, system library, and setting file. All things need to run an application. Docker container is an instance of deploying Docker image. Multiple containers can run on the same machine that at the same time share the operating system kernel and run as independent process in user space. Docker network philosophy is application driven. Docker network isolation is achieved using network namespace. Typically, service gets separate IP and maps to the multiple container. About virtual bridge, it is a piece of software used to unite two or more network bridges. It works like vSwitch and working transparently. About original ACK-Storm attack, depending on the variable handle exception of TCP, page 72 of RFC 793. When a TCP connection is in the established state to receive a packet with not just send acknowledged data, it operates as follows. Send an last send sequence acknowledge number to another party of the connection, then drop the segment and return. Ignore the payload in the segment. The established state has a timeout, so ACK-Storm will stop after a few minutes. For raising the basic ACK-Storm attack, act as a follow scenario. Step 1. Pick up at least one packet from the TCP connection between the client and a server. Step 2. Generate 2 packets, each addressed to one party and with the sender address of the other party. The package must be inside the TCP window with both sides and should have contain at least 1 byte of data. Step 3. Send the packet to the client and the server at the same time. After that, the connection will then enter an infinite loop of sending X packet back and forth between both parties. But this attack method has timeout. For no timeout those attack, we can use ACK-Storm attack using fin X packets proposed by CERN with the same mechanism. But use fin X packet, grid instead X packet, and field expected no need data. According to the description in RFC 793, page 73, if a connection is in closed state, it does the same processing as for the established state. If attacker forks X party running into closed, X party wait for an X packet never come, but not just send X packets instead. Then the ACK-Storm dot trace by 2 field X packets start. Because no timeout by default for closed state, little attack will never stop in theory, and party of the connection will stay in closed state forever. Let's move to the experience. First, we display about our experience in VMware Workstation about the environment with hypervisor with VMware Workstation 14.1.1. Install Windows 10 64-bit for virtual machine server Biaster. For physical computer, host A and hypervisor B have the same configuration as displayed in slideshow. Windows 10 64 and so on. And the attacker C is Windows 10. We use a router because in reality business use a router for establishing their LAN network or connecting to the internet. The router here is Cisco 800 series router Cisco 881K9. For executing original ACK-Storm attack, we use a simple TCP connection created with socket Python script. For the experience, we just let A and B Aster create a connection with a three-way handshake and pick up the last X packet from the connection for sequence and X number. Then we use copy to create fake packets and send to the respective parties. With ACK-Storm attack using fin X package, we just replace X packet by fin packet, and fin packet no need data. Here is the result table. In line A, original ACK-Storm attack, we capture about 55,000 retransmit X packet in 60 seconds while ACK-Storm was occurring. This result is similar to result in previous experience at Hyper mode, but the number of packets is less than because of smaller Ethernet adapter bandwidth. However, Task Manager still display bandwidth used by VMware NAS service was 0.6 megabit per second. This result is much bigger than 120 bytes sent by the attacker. In fin experience, we capture about 86,000 X retransmit packet in 60 seconds. We keep experience for 20 hours and it's still working. This proves that certain idea is correct. The TCP connection is stuck in the closed state while the processing TCP connection is established. Keep running. Depending on this, the attacker could completely raise DDoS attack to hypervisor B. If an attacker could raise a DDoS attack with all available ports, about 65,500 ports, he could play a 19.4 million packet server per second DDoS attack with about 40 gigabit per second and also cause port exhaustion. But in line B, two experience had the same result. Only the first fixed packet which is created forward to the virtual machine B Aster through this week. No retransmit X packets is redirected to the virtual machine B Aster. We assume that this week respond all respan transmit X packet instead of the virtual machine B Aster as long as no reset request is sent between host A and virtual machine B Aster. To prove it, we try the suspending virtual machine B Aster to C, and the ACK-Storm attack is going on. When we resume virtual machine B Aster, nothing happened. This is maybe a feature of VMware Workstation that prevent all invalid packets to virtual machines. Next, we display about our experience in Docker, about the environment. For hypervisor, version of Docker Desktop, Docker Engine, and Docker Compose are displayed in the slideshow. We build a new image depending on base image, Ubuntu 18.04, and install ACK-Storm for monitoring the container activity. We also use TCP dump for monitoring network flow and use Nginx for server. For physical computer and router, we use the same with experience in VMware Workstation. As you can see in figure 7, model experience in Docker is similar to figure 6 for the experience in VMware Workstation, just like VMware Workstation by Docker. In original experience, With TCP connection created by using Chrome to access to the server entity in container Piaster and do the same as experience or ACK-Storm attack in VMware workstation, and we send X packets to each of the respective parties. When each party received a fake X packet, the ACK-Storm was begun. However, the storm was terminated by after 1 second, while TCP connection was timed out after 30 seconds. We capture about 550 retransmit X packets in 1 second. There are still some retransmit X packets generated by original ACK-Storm attack, but the retention is very short. This may be because of the Docker feature or Nginx feature. When the container receives many retransmit X packets with same X or sequence number, this result is not expected, but still prove a vulnerability in TCP connection when receive not just an external data package. Here is the result table. In a FinX experiment, we do the same action with the FinX experience in VMware workstation. But in line A, we just capture a few retransmit X packets between host A and container Piaster before container Piaster side stops responding. In line B, true experience had the same result with the experience in VMware workstation. It seems like we would respond on retransmit X packets instead of Docker container Piaster like this week. Because ACK-Storm attack with FinX packets seem to not work with TCP connection with Docker and Nginx, we propose a new attack method based on it. Firstly, the attacker C creates his own fake TCP connection with server B, then send a fake FinX packet to the server B after dual handshake complete. Constantly then send fake retransmit X packets. Server B, more specifically Vibris, will respond to them and stuck in closed state. With a simple TCP connection, the closed state has no timeout, so we assume server B may be stuck in closed state forever. The detail of this attack method will be described below. About the environment, we use the environment same with original experiment in Docker that describe POL but no host A. We use Skype to create a fake TCP connection with container Piaster as follows. First, create manually and send fake SYN packets to container Piaster. Then, we wait until container Piaster respond a SYN packet, and we create a fake X packet depending on it. After that, send the fake packet to the container Piaster. Done. Then the fake TCP connection is established. After that, we create a fake FinX packet as same as the previous experiment and create a fake retransmit X packet like attacker C receive FinX packet similar to container Piaster. Then we follow the 3 steps. Step 1, send the fake FinX packet to the container Piaster. Step 2, send the fake retransmit X packet to the container Piaster. And step 3, delay about 1 second and repeat step 2. Figure 9 shows TCP communication during the experience in Docker with fake TCP connection and FinX packet. After fake TCP connection is established, when a fake FinX packet is come, the container Piaster enter closed state and respond with invalid retransmit X packet. Then we send constantly the fake retransmit X packet to the container Piaster. As you can see, whenever we receive the fake retransmit X packet from the attacker, it will respond with invalid retransmit X packet. In the experiment, we dump some fin push X packets, but there are no sign of disconnection until the container Piaster send reset packets suddenly. This might be a feature of Vibris or Nginx. When receive too many retransmit ACK packets with the same ACK sequence number, here a short result. In line A, Vibris responds to the fake retransmit packet is valid in transmit ACK packets. After about 10 minutes, container Biaster send an reset packet to close the TCP connection. And in the line B, same result with previous experiment. Eventually, conclusion about feasibility. From the result of the above experience, we have concluded that ACK-Storm attack is possible with basic TCP connection with a virtualized environment. However, this method seem not work with Docker and Nginx, so we propose a new method based on it, but no need eavesdrop ETP connection. An attacker can use a simple Python script with Scrappy to create many connections to the server on the Docker container that use Nginx to occupy ports within 10 minutes and can cause a port exhaustion to Vibris when they combine with a botnet. With just about 10 minutes, but the dam to business will not be small, even though the cost of conducting the attack is not very high. About countermeasure, as we have mentioned above, the Vswitch respond or ignore invalid packet instead of hypervisor on the container and only direct valid packet to them. Therefore, the hypervisor will receive no packet from the client during the ACK-Storm DOS attack, so we can create a timer running on another thread to count the time under responsive from the client and close that connection when timeout. Besides, we can create a duplicate ACK checker to count the number of duplicate retransmitted ACK packets in a physical computer. When the number reaches the maximum, the hypervisor creates its own reset ACK packet to force the connection stop completely. This research emphasizes the proper attention to handling timer vulnerability with global state in a TCP connection when building and developing new software using TCP connection. In this article, we have focused on researching and analyzing deeply the ACK-Storm attack model and proposing a new attack method to capture network port of a virtual server. In the future, we will focus on researching other virtual server systems and propose new attack measure and effective countermeasure. Above is the whole presentation about an attempt to perform this ACK-Storm based attack on virtual and Docker network. Thanks for listening. Any question can send to email in slide.
Hello everyone, my name is Quốc and today I will present for you about our studies identification of chicken disease using VGGNet and ResNet models. Today's agenda has 5 main parts. In the first part, we will introduce for you about our studies. Then, we will talk about some methodologies. The next one is our experimental setup. And then our results, and the last one is the conclusions. Now let's start the presentation. The population is growing in significant number, which boosts the demand for food and require a large amount of protein to support the whole of humanity. Estimated of demand for poultry will result in a relatively healthy and efficient source of protein to feed the world's population will grow to more than 9 billion by 2050. This leads to expected consumption demand that the world will consume 40% more eggs. Vietnam is no exception. According to Vietnam Livestock Magazine, the total meat output reaches over 1 million tons of poultry, 11 billion eggs, Poultry farming is increasing to on average over 6% annually. In only 3 years, the total poultry population increased very high by 6.33%. In 2018, 317 million chickens accounted for 77.6%, while laying hens accounted for 22.44%. The development of poultry industries have led to the development of a disease affecting humans and poultry. In Vietnam, according to the Department of Animal Health, even influenza H5N1 epidemic took place in Vietnam from 2014 to March 2019. Each year, nearly 90,000 poultry were killed, with 127 people affected with bird flu and 65 people died from 2003 to April 2019. The amount spent on prevention is about 180 billion VND per year. The detection of disease in chickens is very urgent issue. But recent studies have focused on solving detailed problems of disease and its origins. In particular, the study of check-steel to detect and reduce new disease in poultry is based on new technology of big data, but only focused on avian influenza virus. In this study, the outdoor check-steel focused on analysis and show the need for a disease detection and reduction system based on gathering information from big data and analysis. In addition, big data is accompanied by data and change during the reduction process based on time variant activities. Unlike check-steel research, Hemelata's team focused on the identification of poultry disease with machine learning methods such as support vector machines (SVM) with Gaussian radio-based functions and extreme learning machine. This study used ray level matches to calculate mean values, standard deviations, noise. They use matches mean square error method to evaluate the performance of the support vector machine model with Gaussian radio-based function. However, Hemelata research stopped at detecting chickenpox in chicken. From the above analysis, it is feasible to identify disease in chickens with the development of machine learning algorithms, including deep convolution neural networks (CNN). Deep CNN is a prediction algorithm using neural network which is widely used in data classification. It consists of a CNN. When building a network, CNN was developed from basic neural network from 1 to 100 layers. From there, it evolved into many different architectures. Therefore, the construction of a prediction system can be based on change in depth and width such as ResNet or VGGNet to classify images. Both algorithms are easier to use in training deeper networks than previously used networks. It is used in image classification studies. In terms of the structure of VGGNet and ResNet, they are relatively similar architectures with many stack layers, making the model learn more deeply, but ResNet easily training with hundreds of layers. Based on the important insights, we propose design recommendations to identify disease in chickens. The contributions of this research are: firstly, we have collected samples from chickens for use in the studies. We can be considered a standard data set for comparisons. Secondly, We report a combination of deep CNN, namely ResNet and VGGNet, to formulate ideas and foundations for building a toolkit that has never been done before. Thirdly, we obtain the result after making the comparisons, assessing the advantages and disadvantages of the two models. The next one is the retrieval methodologies. First of all, we will talking about ResNet 50. This is a network of many residual units stacked on top of each other. The basic idea of ResNet is to yield a uniform of connection to cross one or more layers. Such lock is called a residual lock. Two main locks of ResNet are identity lock and convolutional lock. Identity clock is the standard clock used in ResNet and corresponds to the input trigger scale having the same size with trigger output. Convolutional clock is another clock of ResNet. In general, convolutional clock and identity lock are relatively similar. However, convolutional clock have one convolutional layer in shortcut path by applying linear regression way so that the dimension mask convolutional layer in the shortcut path is used to change the input side to another side of that the dimension mask. The last addition before the shortcut path return to the main path. Secondly, we will talking about VGGNet systems model. The architecture of VGGNet is use 3x3 convolutional layers stay on top of each other in increasing depth, which has to minimize processing size. The two lashes are fully connected, each with 4096 nodes, which are then followed by a submask classified consisting of 138 million parameters. The design principles of VGGNet is generally very simple: 2 or 3 layers convolutions and followed by the mask pooling 2D layers. Immediately after the last convolution is a lasting layer to convert the 4-dimensional matrix of the convolutional layer to a 2-dimensional matrix. Next one, we will talking about our experimental setup. In this research, with the support of animal experts at FVET Vietnam Company, has collected 600 picture samples of chicken disease from 30 to 90 days old. The images were randomly collected in the natural environment like in a band natural stocking. The photo have the same caption of the experts. At the end of the collection process, we obtained a total of 547 samples with 5 layers, of which there were 4 disease lashes and 1 normal lash, which is shown in the screen. In our test, we put the necessary hyperparameters and follows this table. The training rosette on the two models have a big difference in time. The result in VGGNet takes about 200.5 seconds to train, and ResNet it took about 821.3 seconds for our dataset. The ResNet model ran about 4.2 times slower. We randomly divide the dataset into a training set and test set in a 75/25 ratio. The input size of the model to 64/64/3 for height, width, and channel respectively. Their resolution are common settings of running convolutional networks. The classification decision is made at the submask layer where its input is the probability distribution of 5 labels of those chickens. In each combinations, we carefully run the model again and again. However, the exact score does not change, and this table is showing our hardware for the results. The next one is our results. In this work, the training and test accuracy of VGGNet and ResNet are shown in the screen, respectively. By looking at the features, one observes that the result of accuracies are not much different between the two models. The complete performance of 20 different combinations of our models is presented in this screen. Here, it is seen that the best achievement of our model architecture happened at learning rate equals to 0.05. For VGGNet settings, the best classification accuracy is 74.1%, while the minimum one is 65.47%, happen at learning rate of 0.05 and 0.04 respectively. Meanwhile, for ResNet 50, the highest achieved accuracy is 66.91% and the least achieved at 1 is 61.15%, happen for at learning rate of 0.05 and 0.06 correspondingly. In general, VGGNet setting model perform better than ResNet 50, as low to 75% of accuracy. With further 5 tuning steps, VGGNet setting will be suitable for use at poultry plant. The last one is the conclusions. With limited resources, the yield of state-of-the-art deep CNN greatly reduced the time it takes to perform. As seen from the recent work, VGGNet setting is more time efficient and more accurate compared to 50-layer ResNet model. However, VGGNet requires more parameters used for learning deeper the data. The achievable accuracy of approximately 75% by using VGGNet city show the positive results. In future, we will further improve the model's accuracy and deploy the developed application for field trial at poultry plant. Before to end the presentation, we acknowledge the support of staff and management board of FS LLC Vietnam to support us during the duration of data collection and classification. Thank you for listening.
Ladies and gentlemen, on the behalf of the author, I would like to show you the presentation about design and evaluation of the grid-connected solar power system at the stage of DC burst with optimization of modulation frequencies for performance improvement. The power converters are commonly used in distributed energy source, wind power, solar power, and they play a very important role in control systems. In fact, the performance of the DC-DC converter is not constant, but rather depends on the power transmitted through it. Using DC-DC converter will increase the power loss and reducing the energy conversion performance of the entire conversion performance. In this article, we proposed an algorithm to control and simulate the grid-connected solar power system at the DC burst stage by setting an optimal set of SVPWM modulation frequencies when the control value is different, with D is different. The simulation results on MATLAB Simulink shows that the system operates stably, ensures the requirements of DC burst side grid integration. And here is the structure of power block in the system. The DC voltage from solar power source is typically low voltage. Therefore, step-up DC-DC converters are necessary. Meanwhile, the grid power source is the AC power source with fixed frequency and amplitude. The DC burst power is directly supplied to local DC loads. From the DC burst through the DC voltage inverter, it changes to AC at the AC burst. The power of the AC burst is fed to the AC load and connected to the grid through the transformer. And here the detail of the boost DC-DC circuit diagram that we model in the simulation. And here is the detail of half-bridge voltage source inverter. In order to increase the efficiency operating of DC-DC boost, a MPPT software is necessary. In this research, we using INC algorithm. By comparing the instantaneous conductive value with the incremental inductance value, this algorithm will find the maximum power operating point at the MPPT point. The standard voltage we reference equal the MPPT. Every time the MPPT point is detected, panel operation is maintained at this point unless there is a change in the current delta I. A change of current delta I indicates a change of condition of whether an MPPT point. Next, we set up a simulation model on MATLAB Simulink environment. This is the model of solar panel. And here is the model of DC-DC voltage converter, the model of DC power connection diagram, and the model of H-bridge single-phase inverter, and the model of LCL power filter. And here is the PID control. Then we run the simulation model. We get the simulation results. Simulation system is with load 50 ohm when the light intensity is as shown in the figure above, and the temperature is constant 25 centigrade. The DC response at DC burst grid is given in the figure below. From two figures, we can see that the DC voltage on the PV side, VDC, is controlled according to the DC side voltage Vg, and when the PV power source is not sufficient for the load, the DC side voltage is connected to the DC bus system, and the DC voltage on the PV side falls into non-conduction stage. This is the mechanism and principle of connecting DC bus bridge in the system. And here is the results of simulation of both DC-DC units characteristic. The current and voltage characteristic of the boost DC-DC stage are shown in the figures. From the figures, we can see that the time response of boost DC-DC stage has a pulse shape with the same frequency as the SVPWM modulation frequency at the control part. The interruption of the boost DC-DC output current in the figure below shows the DC burst separation of the boost part. At this time, the energy from the rectifier will be fed to the inverter. The phase voltage before filtering at the output of SVPWM inverter is shown in the figure above. The reduced harmonic. To reduce harmonics, an additional LC or LCD power filter is required. Figure below is the Y voltage diagram of the inverter after the power filter. Properly calculating to select the filter and the pulse has frequency will produce a high quality sinusoidal signal while reducing the power value switching loss. And here is the results about system performance. The performance of the system consists of three parts. Performance of rectifier, the DC-DC boost, and the single phase inverter. Note that performance of the inverter has the performance of SVPWM modulation stage and the performance of the power filter stage. The simulation results show that the performance of rectifier, boost unit and inverters is 98%. 86% and 95% respectively, thereby leading to the performance of the whole system is which reaches about 80%. To investigate the impacts of the pulse hashing frequency and the pulse width modulation on the performance of the boost DC-DC, set the system with the following parameters. Light intensity is 1 kilowatt per 1 meter square, and the temperature on the PV we assume that is 25 centigrades, and the voltage hashing frequency at boost DC-DC stage is from 6 to 28 kHz, and the load value is 150 ohm. Simulation results are shown in the table, and we can see that with each case we will get the best performance in the bold letter, as we can see here. And next, either charge or the system performance. From these figures, we can see that the system performance depending on the frequency and width of the voltage harnessing pole width. Increasing the width of the voltage harnessing pole width will reduce the system performance. The pole harnessing frequency also needs to be selected appropriately. If this value is too large, it will cause loss on IGBT protection RC circuits and the valve on or off valve power will increase, resulting in a decrease of performance. With the simulation results, it is recommended to select the working area of D from 0 to 0.4 and the pole has frequency range from 16 to 22 kHz to achieve the highest possible performance. In the case where a large modulation range D with a large range of values must be used, a functional structure that automatically adjusts the pole harnessing frequencies so that the system will achieve the highest possible performance. Conclusion. For the above system, we can realize some advantages as follows. The system operates safely because it does not have to handle the offset phenomenon as in the AC grid system. Control structure and algorithm are simple, easy to adjust and execute. The modulation part of SVPWM does not need to implement the algorithm to stick to the grid. In order to improve converter performance further, in the future, we will first research and develop test the real system based on embedded system platform to get the most accurate evaluation results on grid-connected solar power system, a DC bus station. The second, implement a self-turning mechanism. A voltage has frequency based on the modulation poles width in order to maximize the system performance. The authors wished to thank the Institute of Energy Science and Vietnam Academy of Science and Technology for their support to the research activity of the project, research on completing the technology, constructing and transferring the mode of exploiting and proper using solar and wind energy for production and daily living in Central Highland. Thank you for your listening. And my name is Ning.
Hello everyone, my name is Don. I come from UIT IoT Research Group. UIT Vietnam National University, Ho Chi Minh City. Today I'm very happy for the opportunity to present our paper. This is a predictive system for IoTs reconfiguration based on TensorFlow framework. IoTs are rapidly growing with the addition of new sensors and devices to exciting IoTs. The demands of IoT nodes keeps increasing to adapt to changing environments, conditionals, and application requirements. The need for reconfiguring their already exciting IoT is rapidly increasing. It is also important to manage the intelligent context to execute when it will trigger the appropriate behavior. Many algorithms based on different models for time series sensor data prevision can be used for this purpose. However, each algorithm has its own advantages and disadvantages, resulting in different reconfiguration behavior predictions for its specific IoT applications. Developing an IoT reconfiguration application has differently implementing many different data prediction algorithms for different sensor measurements to find the most suitable algorithm. In this paper, we propose IoT's reconfiguration prediction system (IRPS), a tool that helps IoT developer to choose the most suitable time series sensor data prediction algorithms for trigger IoT's reconfiguration actions. My presentation will begin 5 parts. The first part of this paper is an introduction. The second part is related work about time series sensor data algorithms. The third part discusses the development of IRPS. The next two case study are presented: smart room and smart produce cultivation. And the last one is conclusion and the next future work. Okay, as you know, the rapid evolutions in IoTs, the increases of the complexities of the sensors, and the dynamic change and unpredicted events in the IoT environments expose new challenges to IoT reconfigurations. There are three reasons for the need of IoT reconfiguration. The first, IoT applications are deployed in inaccessible places, dangerous places such as mountain donkeys, deep forests, chemical plants, where people cannot interact or they cannot come to deploy or change the behavior of IoT application. The second IoT system often encounter problems with energy-saving equipment, maintaining time, operating costs. The last one, IoT projects are deployed and maintained. Thus are a number of devices up to thousands of nodes manual. Reprogramming is very hard work. It's impossible for to be done this work. Intelligent context management is influential in the process of triggering the reconfiguration of IoT application. For the problem of reconfiguring IoT application when sensor data is unreliable and improving reconfiguration time, many artificial intelligence techniques have been proposed to build this component brings the problem best to solve the classification and prediction problems. So there is no golden standard for choosing the best algorithm. Psi is an application-specific task, finding techniques and algorithms that fit the criteria, accuracy of decision making, reconfiguration time. This research aims to help developers of IoT solutions to choose the best algorithm for time series sensor data predictions regarding their application data. We develop IoT reconfiguration prediction system, which is also a component of framework or IoT, a web-based online tool that implements 4 different algorithms for time series sensor data prediction. This system uses Google open source TensorFlow framework and puts 1 deep learning algorithm and 2 algorithms are unsupervised learning algorithm, random forest and naive Bayes. The next, we talk about the related work. In reconfiguration mechanisms, some study using reconfigure or reprogram as physical devices. It is a more common way to reconfigure IoT application. The IoT will change their behavior by uploading new binary firmware or just send parameter to change the behavior. In previous study, to address the challenger posed, we have proposed RIoT, RFL IoT, and ROP IoT framework for the reconfiguration of IoT application based on the change of the context and the intelligent context management. The results show that our proposed framework is suitable for remote reconfiguration of IoT application. However, the preceding work this neither apply for complex context and unreliable data. We introduce the algorithms used in IRBS. Time series sensor data predictions is important in IoT's reconfiguration. It helps to make better decisions for trigger reconfiguration action. Different models are used in the literature for time series data prediction. Machine learning and deep learning techniques are the specific subset of AI that are of particular current interest to academic and industry. Machine learning and deep learning are applied to different situations where large and complex datasets are available and metadata, as well as more detailed information could be extracted from the provided data if a table means to extract and link the data were available. The platform we use to build algorithms on models is to use the TensorFlow library. TensorFlow is an open source software developed by Google to performance machine learning, which is widely used by many researchers and law companies. TensorFlow provides many libraries for programmers to demonstrate machine learning algorithm and an application to implement their algorithm. In this session, the system has 3 steps. Step 1, upload the dataset. Step 2, select the input feature and output feature that recognized from the dataset. Step 3, select the algorithm among the 4 mini algorithms in session to train. Once the model has been trained, user can download the model to use for 3D and see results like that accuracy and loss function. The system is based on TensorFlow framework with associated libraries to access online data. The results of the training process according to the data. Algorithms of the user select are 2 files, model.json, ways.by. The prediction system is deployed as CX and the gateway, which do not need powerful hardware. The prediction only needs to select model corresponding to the previously selected algorithm. The data to take according to the given stats. So you can see the feature shows the prediction of controlling room fans opening based on the parameter such as room temperature, outside temperature, where or not people in the room access. Input data, IRPS will implement this. Predict the output fan on or off mode. Based on the prediction result, the system will trigger application behavior change to the IoT framework to perform the next steps of the reconfiguration process. We perform experiments for the two test cases. We will show the actual output of the system and see how it performs on two cases. We consider two different datasets in order to compare the results. The first one is a dataset for a smart room, and the second one has data that shows the smart hydroponics cultivation. In the first case, IRPS is used to predict to change the state of fan and light in each room of the smart room. The framework is also designed in order to collect data from sensors to monitor and store the database. Some features such as noise level, lighting level, access version, outdoor-indoor temperature, window state, and it reconfigures the fan and light state. And as you see, we prepare the datasets for experiments from Kango datasets. This is a time series dataset measured as a smart room from the 27th of November 2016 until 30 July 2017, with a total of 14,573 records. For our reconfiguration prediction, random forest algorithm has worked perfectly in both training time and in terms of accuracy. In the second case, IRPS is used to predict which algorithm is suitable for the problem of hydroponics cultivation. We prepare the dataset for experiment from process of ornamental dragon in Da Nang vegetable garden. This is a time series dataset measured from 27 June 2019 until 30 December 2019, with a total of 404,574 records. The above dataset has a total of 5 features: data time, time of length, staying temperature, ambient temperature, humidity, ppm. Most of the analyzed datasets, as the two previous cases, show the following table: 4 feed-forward neural network with high accuracy. The main reason is that our problem data is not complicated, so the classification algorithm of neural network can work optimally in the distribution problem. However, training time and computing resources are limited to this algorithm. In order to overcome the above limitations, it is possible to use the server to optimize performance and use the save and reload feature that TensorFlow provides to limit the training many times. However, for our problem, the need to train many times is unavoidable because, as stated in the idea, we cannot impose a single rules. For random forest, the algorithm returns amazing predictions when we have never touched normalized data, but the results were really accessible. With over 19% of the correct answer, it also partly reflects the applicability of this algorithm. Building algorithm model by voting in different decision trees has helped random forest become a high appreciated. So in this paper, we present IoT reconfiguration prediction system. that helps future developer IoT application solution to choose the most suitable data prediction algorithm for trigger their reconfiguration action. IRBS perform data prediction for sensor reading using four different algorithms and compare their performance relating to different evaluation metrics. The first one is accuracy to decision making, and the second is reconfiguration time. In future, we continue to our work on improving IRBS such as implementation many AI algorithms into the system to support the intelligent context management of IoT reconfiguration framework. That's on my presentation. Thank you for your attention.
Okay, hello everyone. I am Ngọc Thanh Nguyên from the University of Information Technology, Vietnam National University in Ho Chi Minh City, and together with Minh Sơn Dao and Kosi Setsu from the National Institute of Information and Communications Technology in Japan, we are presenting our paper called Building a Dynamic Predicted Traffic-Congested-Discovery System to Resolve Chaotic Traffic Situations. So, as you may probably know, heavy traffic congestion may potentially cause traffic accidents, especially during heavy rain situations. And when such incidents happen, they will negatively affect the public safety. So, in order to alleviate its burden, many people have decided to build a prediction system to anticipate the future traffic congestion. For example, in our previous studies, we employed the brand data, traffic congestion data, and traffic accident data to supply to our traffic congestion prediction system. The system will then generate the future traffic congestion information. Then, based on the predicted traffic congestion information, the authorities like the traffic control centers or the traffic policemen, they may detect the heavily congested regions or locations. So, for example, here, the region covered in blue squares is predicted to have heavy traffic congestion at 4 p.m. and 8 p.m. respectively on the 18th of July 2015. So, this information indicates that the traffic policeman should closely monitor the traffic situations at the mentioned timing in order to timely react to heavy traffic congestion. Furthermore, when heavy traffic congestion repeatedly happens over a period of time, it becomes a traffic congestion pattern. For example, we have the same region in the previous slide. These regions will have heavy traffic congestion over and over again from 4 p.m. Of the 18th of July 2015 to the midnight of the next day. So the traffic congestion in this region is a traffic congestion pattern. So assume that we can collect many traffic congestion patterns. We can build a database of traffic congestion alert codes. It will provide useful information for the authorities to manage the traffic. For example, here we have a collection of traffic congestion patterns. The locations covered in red are indicated by blue squares, will have heavy periodic frequent traffic congestion, or in other words, they will have high traffic demand. So if we have a collection of traffic congestion patterns, we will rank them based on their popularity, and then we choose the most common patterns. So that we can build a database of traffic congestion alert codes, which contains traffic congestion patterns and their duration of high traffic demand. For example, short term, medium term, and long term. For example, the short term traffic congestion pattern will have high traffic demand lasting for 4 to 8 hours. The medium term traffic congestion pattern will have high traffic demand lasting for 12 to 20 hours, and so on. So based on the information recorded in the database, the authorities and also the citizens, they might think of the rescue and travel plans in advance in order to avoid the impact of heavy traffic congestion. So based on the things discussed previously, we proposed a new method to dynamically discover the future high traffic demand regions. And this method consists of two steps. Firstly, we build a deep learning model called Fusion 3D CNN. It receives a set of 3D multiplayer raster images. They contain the historical data of different urban sensing data sources. The model will then generate a set of 3D single-layer raster images. They contain the future traffic congestion information. Then we will select the locations that have heavy traffic congestion based on the redefined binary threshold beta. So here, for example, we define beta is 200. So it means that the locations that are predicted to have the congested length larger than 200 will be selected. Otherwise, they will be ignored. So then we store the data in a transactional database. In step 2, we supply the data of the transactional database to the BFP Pro++ algorithms. It is an improved version of the BFP Pro algorithms, which stands for Periodic Frequent Button Throw Algorithm. So at the end, the output of our method is a set of the regions that will have high traffic demand in the future. The experiments were done by using a dataset that consists of 3 different urban sensing data sources, namely traffic congestion, rainfall amount, and traffic accident. The data was collected in the city of Kobe, Japan from 2014 to 2015. And based on the experimental results, we proposed 3 promising applications that could be used in the real world to prevent the impact of heavy traffic congestion or high traffic demand. The first application is we will give the authorities about the potentially dangerous regions that may have the long-term high traffic demand, and the duration of high traffic demand could be prolonged. So here, for example, we have a region that has 4 different local areas, M1, M2, M3, and M4. At first, the location M1 and M3 will have short-term high traffic demand, which lasts for 4 to 8 hours, and the heavy traffic congestion in this region is a short-term traffic congestion pattern in the database that we introduced to you in the previous slide. So assume that if the high traffic demand can somehow propagate from the location M3 to M4, this region will have a high traffic demand lasting for 12 to 20 hours. It means that the duration of high traffic demand will be prolonged when the propagation of high traffic demand occurs. And actually, this phenomenon usually happens in the real life, especially during the heavy rain situations, if there is a lack of traffic coordination from the authorities. So, through this example, we give the authority information about the regions that could have high risk of encountering the long-term or extended high traffic demand duration. The second application is we will give the authorities enough information about the future traffic congestion situations of high traffic demand regions. So, for example, here we have a region. It will have 3 locations that will have high traffic demand lasting for 24 hours. The bar charts indicate the future congested length of each location, and the data is provided or predicted by the Fusion 3D CNN model. So, as you can see, looking at the 3 locations, you can see a common pattern of the 3 locations. So here, the congested length predicted by the Fusion 3D CNN model will suddenly of the 3 locations will suddenly increase from the stamp steps T+4 to the stamp steps T+8. So this indicates that if the traffic policeman can somehow manage to resolve the heavy traffic congestion at the time step T+8, the heavy traffic congestion situation in the later stamp steps could be alleviated, and eventually the duration of high traffic demand in this region could be shortened. And the last application is we will give the authorities about the regions that will have long-term high traffic demand. So firstly, in this example, these regions will have high traffic demand lasting for about 8 hours. And as you can see, this region has 3 public hospitals, and they will need to accommodate a large number of vehicles during the business hours. So, here the example indicates that the authorities should allocate their resources and plan strategies to monitor the traffic situations in this region during the business hours, for example, from 8 a.m. to 5 p.m. In order to timely react to heavy traffic congestion. The second application, the second example of this application, as you can see, we have a region that will have high traffic demand lasting for at least 1 day or 24 hours. And as you can see, this region has many highways. Also, there are two targets, and actually the two targets here are the traffic bottlenecks that will significantly slow down the flows of vehicles and eventually cause heavy traffic congestion. So this example gives the authorities information that or suggests the authority that they should permanently allocate their resources to monitor the traffic situation in this region in order to timely react to the heavy traffic congestion. So, in conclusion, in these papers we introduce a new method to dynamically discover the future high traffic demand regions. It was done by integrating the Fusion 3D CNN deep learning model and the PFP Pro++ algorithm. In the experiments, we proposed three promising applications that could be used in the real world to alleviate the impacts of heavy traffic congestion and high traffic demand. So in the future, we will try to improve the predictive accuracy of the Fusion 3D CNN model by using some more data sources and also enhancing the data fusion functions. Also, we'll try to discover new interesting traffic congestion patterns. Okay, that brings us to the end of our presentation. Thank you for your attention.
Ladies and gentlemen, I am honored and proud to have a chance to speak at INISCOM conference today. First of all, let me introduce myself. My name is Đỗ Ngọc Tuấn. I come from Lê Quý Đôn Technical University, Hanoi, Vietnam. Today, I would like to talk about an efficient side channel attack technique with improved correlation power analysis. My presentations will be divided into 5 parts. The first part is introduction. The second part is background of original correlation power analysis, in short form is CPA. And I will show you some related works that improve the CPA. The next part is our proposed technique to improve the computation time of CPA. The remaining 2 parts are experimental result and conclusion. So let me begin with introductions. As you know, electronic cryptographic devices are widely used today for securing the secret information. However, there are emerging issues about side channel attack. In the scope of statistical power analysis attack on cryptographic systems, 2 efficient techniques were proposed. The first one is well-known different power analysis (DPA), introduced by Paul Kocher and formalized by Thomas Messerschmidt. It uses statistical tools to find out the information correlate to the confidential key. The second one is correlation power analysis (CPA), that's proposed by Breer. It exploits the correlation between the power model and real power consumptions in order to leak the secret key. These techniques and measurements are carefully taken into account by embedded system designers to know an attacker can measure the power consumption or electromagnetic emanation, which are 2 of the main physical quantities used for non-invasive attack. In this paper, we focus only on the CPA in order to evaluate the security of the AES cryptography because it is an efficient technique to recover the secret key with a simple power consumption model. And side channel analysis with real devices usually have high levels of noise. Then the efficient attacks requires a large number of power choices. Therefore, finding an efficient way to analyze those power choices is critical. To help you understand our contribution in this paper, I will give you some background about the original CPA. Original CPA used the correlation coefficient to calculate the linear relationship between the real power consumption and power consumption model. Most widely coefficient used is Pearson correlation coefficient, and the formula is shown on the screen as you can see. About the power consumption model, the mostly used model is Hamming distance between 2 relevant values in the same register, or simply the Hamming weight of the particular value. In our paper, we choose the Hamming weight for the power consumption model. This model will calculate how many bits 1 in the results of S-box functions. And the formula of the Hamming weight is shown on the screen as you can see. As mentioned previously, we can see how well the power model and actual power consumption correlations. So from the Pearson correlation formula, we use the formula tree for calculating the correlation of all samples in a power choice with the power consumption model. Because AES is a cryptographic algorithm executing on one byte sparingly, therefore we only focus on the byte that has a lookup position, as illustrated in figure on the screen. To implement Formula Tree, we use the algorithms 1 on the MATLAB software. From the original CPA, many works have proposed to improve the efficiency of CPA. So this slide I will show you some related works which focus on the computing effectiveness. In the reference number 7, the authors introduced a selection method that can be used to reduce the number of power choices. It means reducing L. To review the keys, the authors does not show the computation analysis in terms of execution time. And the authors number 8 presented the partitioning power analysis PPA technique to combine the technique of DPA, multi-bit DPA and CPA in a single form. Despite the enhancement of CPA, the computation time is not presented in this method. Another technique is presented in the reference number 9. The authors shows a new method to recover secret keys with less power consumption choices than the standard CPA. This technique reduces the number of power choices for CPA, but the author does not give any information of computation time. And most recently, in the reference number 10, the authors proposed an algorithm that is similar to the original CPA. This technique is based on the idea of creating an X point in time, a vector of consumption values indexed by the plaintext by values. This method also refers to L and N and has two phases. This method only works well if the number of power choices is large enough. So to tackle the problems in the works mentioned above, we propose new algorithm to implement CPA. As you can see, two figures on screen. The right one is the correlation of all samples calculated by 50 power choices, and it is clear that we have some point have the significantly higher value than the rest, and the red color one is the highest. In this case, we use the algorithm 1 and find out the correct subbyte key is 43. The remarkable thing here is if we calculate with smaller power choice than 50, we still have almost this point have a higher value, as you can see the figure on the left. So our proposed here is divided CPAs in two phases, and the first phase we will calculate to find out the point of interest, which have a higher value than the rest. The novelty of our proposed approach is the optimal chosen parameter. So the figure on the left, we only calculate by a half of power choice, and it's clear that we still have the same positions, have the higher values than the rest. So this is the main technique of our proposal. So in summary, we have two phases. Phase 1, a small number of power choices is used to and denotes as N1. N1 is less than and equal a half of N. The equation 3 is applied to calculate alpha highest samples from all guess keys. The values of alpha is much smaller than L. As you can see the figure illustrated on the screen. This is a figure to illustrate taking 10 samples which have highest correlation values. Phase 2, the equation 3 is used again to compute the correlation for all hypothesis keys. However, only alpha samples are calculated instead of using L samples as the first phase. The figures on the right illustrate the correlation of 10 samples calculated in phase 1, and the first point is the highest value. To implement our proposed algorithm, we use the algorithm tool on the MATLAB software. To prove the practical effectiveness of the proposed technique, let me move to the part 4, experimental results. In this experiment, we use the synchronous and low noise power choice of low frequency AES implementation acquired on chip whisper board, and then the Gaussian noise is added to illustrate the real environment. These figures on the screen show the results of proposed CPA technique with the sum of N1 values. The best result of CPA is with N1 equal 1/3 N. And the more noise is added, higher N1 is needed for extracting secret key successfully. To demonstrate the effectiveness of timing execution, the proposed algorithm is implemented with the same configurations of the conventional CPA algorithm. In this experiment, we used a number of power choices in the range from 1000 to 10,000, corresponding to the standard deviation of noise ranging from 0.06 to 0.15, and with N1 equal 1/3 N. These parameters are listed in the table shown on the screen. And the figure on the screen on the right shows the results of experiment. It can be seen that the proposed technique is much faster than conventional CPA. As expected, the values of N1 directly affect the calculation time, and it is effective with the broad range of number of power choice, not only the last number as the reference number 10. So, for conclusions, in this paper, we have proposed a new CPA method in order to recover the secret key. This technique contains two phases. The first phase calculates the number of points of interest of all possible key bytes, very small compared to the number of power choice samples. Then, The points of interest are used to compute the highest correlation values of all gas key bytes. The effectiveness in terms of execution time is demonstrated in experiments with various number of power traces, which have clarified the efficiency of the proposed method. In the future work, mathematical representation and analysis will be investigated in detail. So this is my presentation for our paper. Thank you for your attention.
Hello everyone, my name is Đào Thị Nga. I'm from Lê Quý Đôn Technical University, and today is my honor to present to you the conference paper with the title An Optimal Packet Assignment Algorithm for Multiple Level Network Intrusion Detection Systems. Before I begin, let me introduce to you the presentation content. First, I will introduce the network intrusion detection problem, and then the detailed problem formulation and problem algorithm will be presented, and lastly we will show you the results of the optimal packet assignment method. As you may know, network attacks includes unauthorized activity against specific networks or computers in order to destroy the system, steal or modify data. There are some types of common attacks, including reconnaissance attack. In this attack, they try to scan the active ports so they can know the possible vulnerabilities of your system. And in the man-of-the-meter attack, they will try to illegally read your data packet and then try to change the information before forwarding to the destination. And for the denial of service attack, the attacker wants to suspend the host services and computer resources by sending a lot of packets to the victim devices. And in the botnet malware, they want to turn your computer running on Linux into remotely controlled bots, so it can become a part of botnet in large-scale network attacks. Then they will run some kind of attacks, for example, DOS. In this work, we consider a system with 3 different levels. The lowest level is the sensors or data generated sources. For example, the wireless body network, computers, camera, or even UAV. And these sensors will generate data and send to the gateway, and from the gateway this data will be transmitted to the desired servers. And so this is the lowest level. And for the middle level, we have networking device, for example, gateways, routers, switches, and this networking device is the middle part of the network. They has a mission of forwarding packet to the dedicated servers. And in the highest layer, we have servers which has which have powerful computing unit and also large memory size. So it can store the data and also can perform some specific mission like intrusion detection. So as you may know, the number of attacks increase significantly over time, so there is a need for an effective network intrusion detection system. So in this work, we consider two different requirements for the network intrusion detection system. The first one is a high detection accuracy, and the second one is we need to have a system with low detection time. So let's take a look at the capability of devices due for network intrusion detection. The first one is powerful servers. They can provide high detection accuracy, but also they need high detection time. Whereas the network devices can achieve shorter detection time, but they only give us lower accuracy. So there is a need for multi-level network intrusion detection system which can combine both powerful servers and networking devices, so they can balance between two different factors, detection accuracy and latency. So this is the main goal of our paper. So now let's take a look at the problem formulation and the proposed algorithm. First, we assume that three types of devices in the network. One is the end devices, or we can say package generators, for example sensors, mobile phones, etc. And there are two types of nodes which can perform intrusion detection. First one is the networking devices, and the second one is powerful devices. And the characteristics of these devices we also presented in the previous slide. And we consider different parameters of nodes. For example, type devices, networking device or servers, or the number of arriving packets per second, the number of packets to be inspected per second, detection accuracy, and detection time. So in this paper, we consider the problem that assigns nodes to perform intrusion detection of a specific end devices so that they can meet accuracy and time requirement. This is our problem. So in order to solve this problem, we first explain the detailed formulation like this. We use Yij to denote the assignment of node J for packets from sensor I. If this value equals 1, so that means we assign node J to perform network intrusion detection from packet from sensor I. And we also define Hij as the number of hop counts from sensor I to node J, or we can say that is latency between sensor I and node J. And we have AJ1 and AJ2. They are attack detection and classification capacity of node J. And in this paper, we try to minimize the average detection time with 4 different constraints. The first one is average detection accuracy, and the second one is average classification accuracy, and the last one is it needs to satisfy packet processing requirement. So in order to solve the above mentioned problems, we propose one algorithm which contains two different phases. The first phase is independent assignment phase. In this phase, nodes are assigned packets independently based on detection accuracy constraints. So we define Pj as assignment probability of node J, and then we calculate the average detection accuracy AD, which is the average value between nodes. Then we can calculate the assignment probability of node J, and then node J will be assigned the packet based on this probability. And in the next phase, it's a collaborative assignment phase. If the current assignment meets the bandwidth constraint, so we can stop the algorithm. Otherwise, we need to ask neighboring networking devices or closest server to perform intrusion detection. The detail of the proposed algorithm can be found in this figure. So let me move to the experiment results. We consider a dataset which contains 155,000 training samples and 80,000 test samples, and there are 9 types of network attacks, and they provide us 48 traffic features. And in this paper, we consider different parameters of network scenarios. For example, the number of gateways, the number of servers, the number of sub-networks, the processing capacity of gateways, and the number of available ports at each gateway, data rate of each subnetwork, and intrusion detection accuracy requirement. In order to better understand the packet assignment at different phases, we showed you the packet assignment at different phases like this. At the beginning, there's no assignment at all. And in the next phase, the assignment is performed based on the accuracy constraint. And for the last one, we need to do fine-tuning the assignment so the bandwidth constraint can be met. For the result, first we compare the performance of processing nodes. Since gateways usually has lower computing, it has lower memory size and also limited computing capabilities, so we only use a logistic regression-based intrusion detection model for networking device, and it can achieve 70% accuracy. And for the servers nodes, we use new network-based intrusion detection and accuracy, and the performance is 86 and 73% respectively. And the last one, we compare the performance of proposed algorithm with optimal brute force based algorithm. So there are two metrics. First is the detection time, and the second one is detection accuracy. And we also consider two different number of subnetworks, 15 and 21. And as you can see that the detection time of the proposed algorithm is a little bit higher than the optimal brute force algorithm. However, the detection accuracy is quite similar. So we can say that the proposed algorithm, it can achieve nearly the performance is very close to the optimal algorithm. So, and in this table, please note that the T0 is the time, the transmission time between one hop in the network. And detection accuracy here, which means the average detection accuracy. So thank you very much for your attention. So if you have any question, please let me know. Thank you.
Hello everyone, I'm going to talk about privacy reserving for web hosting. So firstly, I will briefly talk about motivation, then I will show the three models and the privacy requirement for the decentralized web hosting, and then I will introduce our proposed solution to meet the requirements. Finally, I will show some experiment results. Nowadays, almost web applications are implemented on the client-server architecture, where the central servers are responsible for storing source and data of website and processing queries from users. And users can use their web browsers to send requests to the web server. There are two challenges for this model. Firstly, availability. Which website provide data sharing features when the number of requests to log files increase significantly? The network traffic becomes more congested and hosting servers become slower in responding. If central systems stop working due to overload, denial of service, or distributed of service attacks, users cannot access the website at that time. Secondly, data security. Data can be accessed, altered, or removed by any people with control of the systems. To overcome limitation of the client-server model, we have already proposed a decentralized solution for web hosting using IPFS and blockchain, in which IPFS is used to store websites and distribute them to users. Blockchain is used to manage the website, manage the web hosting service. In this paper, I present three models of decentralized web hosting, and we propose a solution for privacy reserving for web and on decentralized system. The decentralized solution for web hosting can be implemented on the three models. As shown in Figure 8, the service provider use some nodes having high performance, especially large storage capacity to run the IBFS cluster service, which is used for data replication between cluster nodes on websites of customers are stored long-term and replicated on the nodes. Other nodes called minor nodes must connect to cluster nodes directly or indirectly and act as gateways of the network. The size of network is the number of nodes on the network. User can use web browsers to access websites through one of the gateway nodes, or each user use a device to join the networks as a node of the network and use a web browser to access website via the local address of the joined device. This way is recommended for user because it reduces the network congestion at gateway nodes and user can access website faster. Figure B. The model is the combination of the two private IBFS networks of the two service providers to form a new private IBFS network. In fact, the more network joins, the more effective the IBFS network operates. However, the models in A and B can only operate effectively within areas that the network covers because many nodes of the service provider are always in active state to serve users. Users in other regions do not always join the network to access or get data for other nodes in the regions. Hence, the stability of the IBFS network will not be guaranteed. The model in Figure B is suitable for service providers whose websites only serve users in a special geographical area such as a region or a country. In order to serve a lot of users around the world effectively, the service provider network needs to join the IBFS network, the public IBFS network. Currently, IBFS.io is one of the largest public IBFS networks. It built by the protocol labs. None of the service providers can easily join this network to form a private IBFS network and operate based on the public network. In Figure C, you can see nodes 1, 2, 3, and 4 join the public IBFS network. This is suitable model for web hosting, with lower deployment costs than the two previous models. It is also selected for the experiment recession. In order to implement this solution into practice, it is necessary to consider aspects concerning security and privacy for the service. We indicate three requirements that need to show for the decentralized web hosting, including protecting customer information, guarantee the security and privacy of website support when transmitting from customer to the service provider for hosting, and protect website from illegal copying. The first requirement can be solved by using blockchain. The user only needs to create a wallet on the blockchain network to conduct transactions to the service provider without using real information. With the second requirement, we can use cryptography to protect data privacy, and service provider can build a special application for users to access website. Our proposed protocol for web hosting satisfies the privacy requirements. The symbol in the diagrams as follows. The PO represents a person or an organization who owns a website and wants to register the web hosting service. Each PO has a public key and a private key denoted PPO and PPO respectively. The web hosting service provider is denoted by SP and also has a public key and a private key. To register the web hosting service, firstly, the PO build a website, and then the PO encrypts the website with a secret key denoted by K1 and selects a symmetric cryptography. The PO can use a crypto system provided by the service provider, or in case of using a private crypto system, the PO must provide the crypto system or so cost of the crypto system to the service provider for decryption. Then the PO uploads the ciphertext of the website to the IBFS network. After upload process has accomplished, the PO receives a hash value of the ciphertext from the IBFS node. The PO make and submit a transaction to blockchain network. In this transaction, besides the information about sender and receiver address, it also has the following necessary information: encrypted secret key using public key of the service provider, and the link of the ciphertext on the public IBFS network. When service provider gets the secret key and using and the link of the website in the IBFS network, the SP downloads the ciphertext of the website on the IBFS network and use the secret key to decrypt and get the source code of the website. The service provider use a symmetric cryptography and a secret key to encrypt the website. The output is uploaded to a cluster node of the service provider. The return hash value is mapped to a certain public key by the IBNet service of the IBFS. The service provider create and submit a transaction to the blockchain network to return IBNS value to the PO. The PO can use this value to configure a domain name for the website by using the TXT record of the domain name system. In order to access the website, user have to download an application provided by the service provider. This application can show website hosted by the SP because it contains the secret key of the service provider for decrypting website. In case the PO want to update the source code of the website, the PO have to perform steps similar to the service registration process. In case to deploy this protocol, we use the IBFS.io network, which is a public IBFS network. For blockchain network, we use ResNet to create a virtual Ethereum blockchain. We use C# programming language to create an application naming web client will contain the key for decrypting the source code of the website. Two main functions are smart contract, submit data, and submit IDNS. With the submit data function, there are two parameters, key and link, and this is the function of submit IDNS EU from EU to transmit the hash value from the service provider to user, to customers. To join the published IBM network, we installed an agent provided the network. The figure shows the node information, peer ID, and version. You can see on in the slide, peer ID and the version. The name of the application IBM desktop setup is easily. After receiving the website from a customer, the website is encrypted by a symmetric encryption and uploaded to the IBM network. The hash value of the website folder on the IBM network as shown on the slide. This is the hash value of the folder contain the website. This is the node of the service provider. On user on the network, when using a normal web browser like Chrome Firefox, user only see the ciphertext of the website, so the privacy is protected. You can see the on user on the network access the website through the IDNS value, and the content we cannot see anything. Cannot see the plain text. To access the website, user can access through the gateway node, or can join the network and access via local address, as shown in this slide. When user use a web client, the website is decrypted and displayed on the interface. This is the special application is prevent illegal copying. A user cannot right-click and view source code of the website. Conclusion: in this paper, we have viewed a protocol for web hosting presented on the previous paper. Our protocol can protect the privacy of website on the public IBM network. Protocol is built from the advantage of the IBM platform for storing, distribution, the blockchain technology for providing anonymous, and cryptography for protecting confidentiality and authentication. The experiment results show that our protocol operates effectively, can easily implement in practice. This research is funded by Vietnam National University, Ho Chi Minh City, under grant number NCM 2019-1801. Thank you for your attention.
Good morning, everybody. My name is Trương Văn Trương. I am PhD student in computer science from Utang University, Vietnam. Today, I am going to present the paper titled "A Novel Secure Protocol for Mobile Edge Computing Applies Downlink NOMA in INISCOM Conference." My presentation is divided into four parts. The first one I will give you some general information about the mobile edge computing at NOMA. Next, I summarize some related work and emphasize the main contribution of our work. The second one, I will talk about the system model, the assumption, the communication protocol, and time flow chart. The third one, I will discuss about the performance analysis with detailed mathematical formula. And the last one, I will give you some numerical result and discussion. Okay, let's go to the introduction session. As you know, the last decade has seen cloud computing emerging as a new paradigm of computing. Cloud computing has been driving the rapid growth of many internet companies. For example, Amazon, Dropbox, Microsoft. However, in recent years, a new trend in computing is happening with the function of cloud being increasingly moving to the network edge. It is estimated that tens of billions of edge devices will be deployed in the near future. This paradigm is called mobile edge computing (MEC). In this MEC network, the edge server works as a computational access point to help in accomplish the computation task of user through wireless link. With short propagation distance and simple protocol, the user can reach very low latency within the limited energy and computation capability. Meanwhile, the application of NOMA contributes to the realization of the MEC model. NOMA is capable of simultaneously serving a large number of users with extremely high data rate and very low latency in the same time and same frequency resource. So, the application of NOMA in the MEC is considered to improve the performance of the MEC network. The next one, I want to talk to you some related work. The first one is the paper of EAI on the performance of optimization from MEC network using uplink NOMA. The author proposed the NOMA MEC network, in which the two users upload their task to a single MEC server through the uplink NOMA. The user can choose one of three different uploading schemics, namely parallel computation uploading, complete local computation, and complete uploading. The optimal solution for an optimization problem to maximize the successful computation probability were attained by only optimizing the parameter of the robotic scheme. Another word I want to introduce to you is belong to Zhao add-on in computation efficiency in the wireless boundary mobile computing with NOMA. They propose a wireless boundary MEC network based on uplink NOMA. The user can use the parallel and binary uploading mode. The author proposed two algorithms to solve the computation efficiency problem. Or the next one, the works multi-antenna NOMA for computing uploading in multi-user mobile edge computing system, OS1 add-on. The author proposed the algorithm to solve the weighted summary minimizing problem for both case with parallel and binary uploading from multiple antenna, multiple user MEC system. And the last one, the work belongs to the DIN add-on. It is the impact of NOMA on the uploading on mobile edge computing. They study about the NOMA MEC network for both case uplink and downlink transmission. The result of this study proves that the use of NOMA can reduce the latency and energy consumption of the MEC compared to the OMA. The next one, I want to talk to you about the main contribution. Our main contribution in this work, we consider the security of downlink NOMA MEC network based on just this server, in which, due to the security constraint, the confidential tasks are computed on just this server, and remaining tasks can be uploaded to other server if needed. Our contribution are as follows. We have 4 contributions. The first one, a noble secure ABS NOMA MEC schematic for mobile edge computing applied Darwin NOMA network by on justice server is proposed. The next, the excess closed form expression of successful computation probability in this schematic is derived. The third one, the numerical results are provided to investigate the impact of the network parameter on the system performance to verify the effectiveness of deployment of NOMA in MEC network. And the last contribution, the numerical result show our proboscis protocol can achieve better successful computation probability compared with other NOMA schematics. In the next session, I will talk to you about the system model. You can see in the figure 1. This is the system model for a secure downlink NOMA MEC network, in which one user S, this one user S, partially upload its task to a two MEC access point, this one and this one. The IP1 is a justice access point and IP2 is an unjustice access point. We call G1 and G2 is the relay channel gain. All of them are the single antenna and operate in the half duplex mode. We assuming that the S has L bits tasks with L1 confidential bits to be computed, and it may not be able to compute its task locally within time delay budgets due to the limited computation ability. Therefore, the user S needs the help of the access point IP1 and IP2 to complete its task. However, due to security constraint, the justice IP1 must be prioritized to selecting to compute the task of S. Meanwhile, the unjustice IP2 is only used to improve the performance of the considered system if needed. Next one, we propose a new secure protocol called ABS NOMA for MEC network as follows. The protocol has four phases. The first phase, the S estimates the channel parameter at the beginning of each transmission in a duration tau 0. In the second phase, it decides to select the access point and upload its task to corresponding access point during tau 1 according to the algorithm 1. You can see the algorithm 1 is here, in which the task 1 is a confidential task with L1 bits, and task 2 is a non-confidential task with L2 bits. In the first phase, the data is computed on the select access point in duration tau 2, and finally, the last phase, S downloads the result from access point during tau 3. Okay, we go to the performance analysis. In this session, we analyze the performance by derivation the expression of the successful computation probability (BRS). It is defined as the probability that all tasks are successfully computed within a given time t. The formula given by this one, BRS equal PR of tau 1 as tau 2 is less than t, in which the tau 1 is transmission latency and tau 2 is computation latency. We easily attain the bottom formula, this one, because we can see if J1 is larger than J2, the S all the way to the justice access point and the first factor, this one, first factor, L divides B logarithm 1 S the gamma S J1. In L is the task bits, B is the bandwidth. Because S all the way to the justice access point 1 and the first factor in the formula, so the first factor in the formula in the transmission latency is the transmission latency. And the second one is the computation latency. For accessible IP1, computation will be start. Next one, if J1 is less than J2, the total transmission latency and computation latency for uploading to accessible 1 and accessible 2 have to less than T. In other words, the maximum of latency has to less than T. In order to evaluate the performance of this considered NOMA MEC system, we attend the following theorem. The theorem 1. Under relay fading, the excess closed-form expression of the successful computation probability BRS for ABS NOMA MEC schematic of the considered Downlink NOMA MEC system is given by this one, is given by this formula. We prove it in Appendix A. The theorem 2, under relay fading, the excess closed-form expression of the successful computation probability BRS reference for the conventional Downlink NOMA MEC system is expressed as this one. This formula is proved in the Appendix B. This theorem is to verify the effectiveness of the proposed protocol. Okay, we go to the last session, the numerical result and discussion. We use the Monte Carlo simulation to verify the analytical result. The simulation parameters used in this work are provided in table 1. You can see here the transmit power PS, the CPU cycle of the IP1 S1 is 5 GHz, S2 is 10 GHz. The number of CPU cycle to compute one bit input is rho is 10. The channel bandwidth is B, 100 MHz. The T, the threshold of latency, the maximum latency allowed in this system is 1.5 seconds. The number of data bits L is 80 megabits. Okay. The first one, we investigate the impulse of average transmit SNR and the length of start 1. We let L1 is epsilon L and L2 is 1 minus epsilon L, where epsilon is denoted as data allocation. We set power allocation ratio as A equal 1.75. We observe in the figure 3 and figure 4 when the average transmit SNR increase, the BRS increase. In other words, the performance can improve by increasing the transmit power of user. Meanwhile, the variation of L1 does not affect to the performance much. However, there exists an optimal value of L1 star corresponding to the epsilon star for BRS achieve the maximum value. Next, we investigate the impulse of transmit power allocation ratio. For given value of epsilon, BRS increase when A is larger than phi divided 1 minus phi. And it does not change when the A less than this value. It means that in order to improve the performance of this considered system, we can allocate the more transmit power, the better. However, when I move to 1, the performance decreases. Therefore, there exists an optimal value A star. Thus, PRS achieves the maximum value. And the last one, we compare our schematic to conventional NOMA schematic. We can see in the figures 9 and 10 that our proposed protocol outperforms to conventional NOMA schematic in terms of successful computation probability. And the final conclusion of our work. In this paper, we have proposed the new uploading ABS NOMA MEC scheme for a secure NOMA MEC network. We have also derived the exact closed form expression of successful computation probability for this process system. The numerical results have been provided to reveal that our proposed scheme achieve better performance than conventional NOMA scheme. Moreover, the performance of this system can be improved by increasing the transmit power and or by select the optimal value of power allocation ratio. That is all of my presentation. Thank you for your attention.
Esteemed authors, distinguished participants, and dear friends, I am Nguyen Sơn Võ from Yitan University, Vietnam. On behalf of the TBC Jazz of the conference, I'd like to say thanks and congratulations to all of your contribution to the success of the conference. Before closing this conference, I have the distinct honor to present the TPC Jazz in announcing the Best Paper Award of the Industrial Network and Intelligent System Conference in 2020. After carefully reviewing all the accepted papers, there are two papers selected for the Best Paper Awards. The first one is the paper entitled "An UAV and Distributed STBC for Wireless Relay Networks in Search and Rescue Operation" by Công Hoàng Diễm and Takefuji. And the second one is the paper entitled "Intelligent Channel Utilization Discovery in Drone-to-Drone Networks for Smart Cities" by Muhammad Rashid Arrow and Bert Canbert. Congratulations to our Best Paper Awards. In closing the conference, once again, we'd like to thank all the authors, the keynote speakers, the track judges, the TPC members, the reviewers, and the excellent organizing committee team for all of their contributions to the conference. Special thanks goes to the Springer for their technical sponsorship, and we would also like to recognize our organizer and financial sponsors, Lê Quý Đôn Technical University and Yitan University in Vietnam, the European Alliance for Innovation, the Newton Fund Institutional Link through the Fly-by-Flash Monitoring Project under Grant ID 428-328-486 delivered by the British Council. Finally, we hope you all have enjoyed the conference in 2020 and coming back next year to contribute to the Future Industrial Networks and Intelligent System Conference in Hanoi, Vietnam in April 2021. Thank you very much.